It's me again. I'm going to teach you the math on how to use the graphs in the following videos, including this one for evaporation of seawater. I would like you to read in the labs the processes that went about to get us to this point, to the math. All right, here we go. Exercise 13.1 in the middle of page 3, evaporation of seawater. To calculate the salinity of each of the samples, use the following formula in combination with the data provided on the page below. So this is a little piece that I've cut out and stuck onto this slide, but as you're going to see, if you have the lab open, you'll notice that when I go to the next slide, that's just a little bit below this particular part of the page. Well, here's the formula, which is the most important part here. Weight of seawater residue, which is going to be the salt, divided by the weight of the original seawater sample times 1,000 gives you salinity in parts per thousand. Okay, take a look at that. Here we go. So in the middle of page 3, you can see here's the math. Determine the salinity of the samples below. First, notice that there is a sample A and a sample B. Then notice that you have the weight of the original seawater sample. In this case, for both of them, it's 10 grams. So that's how much the water that was taken out of the ocean weighed. You can see the weight of the empty dish, the weight of the dish and salt residue, and then you're solving for the weight of the salt and the salinity in parts per thousand. And remember, you are going to use, to solve for salinity, this formula, weight of the seawater residue, which is the salt, divided by the weight of the original seawater sample times 1,000. All right? These are the numbers we're going to work with. But I'm going to do a pseudo problem. So I'm not actually going to use those numbers because you're going to use those numbers. So I'm going to make up other numbers, and then that will act as our practice, and then you're going to solve for these actual numbers for sample A and sample B. So we'll call this sample 1, I guess. Here we go. We want to solve for the weight of the salt. The way this is going to happen is you're going to take the larger number and subtract the smaller number. Now, if that was sample A, you'd be taking 41.858 grams and subtract 41.5 grams. Because what happened was you had a dish that weighed 41.5 grams. It was empty. You took 10 grams of water and poured it into that dish. Then you put that dish into the oven and dried it out. Once all the water evaporated, what was left behind was the dish and the salt, which weighed 41.858 grams. In order to solve for the salt, what the weight of the salt is, you just take the weight of the dish and the salt and subtract the weight of the dish, and now you have the weight of the salt. Let's practice it. So, we're going to pretend for our practice problem, our sample 1, that the dish weighs 41 grams. You can see that down below. And after we evaporate the water, we're going to assume this, that the weight of the dish and the salt is 41.454 grams. What do? We take 41.454, the larger number, subtract 41, and we come up with 0.454. This is the weight of the salt. That's what would go in that area I circled that says weight of the salt, if these were the numbers. But remember, you are going to solve for A and B. Now we want to get salinity. Well, we're going to use the formula. So what we're going to do is take the salt residue, which is 0.454, and we're going to divide that by 10, which is the weight of the original seawater sample. We're just assuming that that is the weight of the seawater sample. We're keeping that consistent as I'm going through this. So you just take your calculator, you put 0.454, I'm doing it right now, divided by 10 equals 0.0454. And then you multiply that by 1,000, doing it also right now. And the answer is 45.4. That's your answer. You like that? Think you could do this? 45.4 parts per thousand. That's very salty water. That would go where salinity's at. See where salinity's at? You put 45.4 parts per thousand. Very good.